you're going to need Geogebra, first you want to get your y equals sine x graph in there. So, and let's call it f of x. Sine of x. Alright, I think you've seen this before. Now, let's get it scaled up a little better, because we only are going to do it from 0 to 2 pi. So I'm going to change this and stretch this out a little bit. 2 pi is a little over 6, so there's that one cycle. Let's stretch this up a little bit too. So there you go. Nice picture of the sine. Right. Now, we're supposed to plot points and plot tangent lines every pi over 4 radians. So let's start first with the tangent line right at the origin, 0, 0. 0, comma, and then we're going to go f of 0. Now I know that's 0, but you might not remember that from the trick, but you don't have to. I'm going to show you the trick. You can actually have the calculator plot the point on it. And you want it exactly at 0, 0. And so now to do a tangent line, you can go to this section over here where it says tangents. And it says select a point or line, then circle, conic, or function. So we select the point A, and then select that function, and there's your tangent line. Now, not only that, is it's telling you the slope of the line, because you can look at y equals a, y equals x of 1. So that's got a slope of 1. So that means on your derivative graph, you plot 0, comma 1. Because the original function and the derivative will share a common x, but they'll have different y's. So keep that in mind. 0, 1 is one of the things we're going to plot in the derivative graph. And we can do that right now, too. We're going to plot the point 0, comma 1. That corresponds to the slope. The slope of this line has now been represented by a point on a new graph. Now, we're supposed to go over pi over 4. So, I don't want to try to guess what pi over 4 is. We just use the calculator. Pi. You come over here, the little alpha symbols over here. Pi over 4, comma, I can't remember what the sign of pi over 4 is. Anybody? No, I don't think so. Sure, we'll come back to you in the second semester. So we can go with we can just say, you don't even have to write out sine because we already wrote it out as f, right? F of, now let's put pi over 4 in. Pi divided by 4.
I think you have an extra parenthesis.
Thanks. Now I got the right number because of the way it was in parentheses. Okay, see that's on the function, right? And now we go through that process again. So graph, tangent line, pick the point, the thing it's on, it's much reduced. Because you're starting to go up the curve and it's slowing down the curve, so it's very increase. And notice here now the slope is about 0.71. I'd like a little more precision here, so go to options, rounding, let's go more like a 4. So 0.7107. So that's the next point we want to plot that on a new graph. What is that? Put that down there. No, that's just wrong. Get that out. Okay? That's green light. Good? Okay. So now we're going to plot the point pi over 4. Where'd you go, pi over 4? Pi over 4, comma, and we're going to grab the slope of this line there, 0.7071. 0.7071. There you go. Now, do you see how D overlapped with another point we had there already? Wait, did it graph it?
No.
I think it did. No, it didn't? Yeah, I think it did. Yeah.
It's right on top of C.
It's right on top of C. Yeah. Point C and D are the same thing. So there's one point where the original function and its derivative have a common point. You can have it. Let's try one more. The next pi over 4. 2 pi over 4. Because we're going to do pi over 4, right? Come on, somebody say, silly Mr. Lang! 2 pi over 4. You can reduce it.
Half pi.
Half pi. Pi over 2. Pi over 2, do you remember what pi over 2, the significance of pi over 2 is? In radians? It'll be the peak. It's 90 degrees. It's pi over 2. And that's where the sine reaches its peak. Let's find out. 2 pi save me some. Oh, I could have cut and pasted it. Oh, well, maybe next time. Boom, there's E. And now we go to graphing that tangent line. Point, line, boom. Right? Now, it may have implied in the instruction that I expect you to create these tangent lines by putting 2 points together. You don't have to do that. You can do it the way I'm doing it here. Okay? I mean, if you want to recall how we came up with the derivative originally, we had a secant line, and we slowly turned it into a tangent line, and having the 2 points become 1. But when I have students do that, they kind of get slightly off answers and so forth. This way we get that real crisp answer. And what's the slope here? What's the slope of y equals 1? Careful.
0.
But you see that little trick there I did there? I knew it was going to have the same x coordinate, so I'm saving myself a little time here. By just copying, by right-clicking and copying it to the input bar. So now we're going to get a new point at 1.578, that's pi over 2. F of, hopefully let me just cut and paste this. Yeah. Put it into there. There you go. Oh, what happened? Was that not a point? Didn't I just make a point? Yeah, it's this one, right? Oh, oops. So sorry. Our point F, we're supposed to have a different y coordinate. We're supposed to read the y coordinate off of the slope of, what's the slope of this line, tangent line we just drew? I'm not taking a class.
0.
0! So we put a 0 there. And that's the point down there. Okay. So far you've got 3 points already on the derivative graph. And will it keep going down? What's going to happen when we come over here? That's a negative slope, so the derivative point will be down here. But then at some point, it's going to start getting less negative, so what's the slope right here? 0. And we get a slope over here of 0 as well. So you're going to travel down, come back to 0, and then come back to 0 again. And it's the cosine. And it's okay giving it away. You should get a cosine graph. So, your picture's going to get a little messed up because you're going to have a tangent line for each one of these 9 points. 1, 2, 3, 4, 5, 6, 7, 8, 9. Right. You're going to stop here, right? I went too far this way. But by the time you get up here, you're going to be positive. It's going to be like this one. Okay? And then you just sketch it in through those points. Okay? Does that help? Can they give what I'm looking for in that activity then? So what do you have to submit? Submit this. Submit your and also print it up so I can see all your tangent lines.
How do you fit that with the size? The shipping tool or
You're going to have to cut and paste it from, you do a window capture from whatever kind of notepad you're working with.
And then you put it in. How do you do window capture? Search snip tool and start. Yeah, it's called snipping tool. What is it?
If you're doing it at school, you can just do it with print screen. You can just print what's on the screen. The screen capture thing.
Yeah, you can do that too.
Yeah, print screen right there. That's one way to do it too.
It's PRT.
Yeah, it's toward the middle of the top here. Okay? Check it out. Better stop it. Yes?
Do you ask for all the tests?